Hi everybody, I hope you're doing well. So yesterday we started the next unit with an introduction to waves, and I had you guys watch 3 videos on YouTube and then take some notes on that. So the videos, first one, Mr. Anderson from BozemanPhysics.com, he's really good. I'm sure you'll be seeing more videos from him in the future. The second one, I wasn't familiar with that source, but it seemed like a good video pertaining to what I wanted you guys to get out of it, so I assigned that one. And then the third one, Flipping Physics, that guy, I really like him. I'll have you watch those videos occasionally, but he's more on the AP Physics level. Not saying you can't handle that, but there's just some things in there that you won't need. But that certainly was a good video, so I hope you learned some things from him. So today I just want to go over some things, review a little bit from that, and then kind of get you going on the next area that we're going to be looking at. Okay, so you took notes on the anatomy of the wave. So I have that same wave drawn right here. So some things that I just want to go over real quick. By the way, I'm going to put that answer key on Canvas, so make sure you check Canvas, make sure you have everything correct in there. And if you have any questions, let me know. But for the wave, so I've drawn the wave like this. Now, in reality, the wave is going to be moving. We often just draw it. It looks like it's stationary, but it will be moving. I don't know if I can get this to move, but I thought I could highlight it and get it to move. Anyway, let's say in this case it's just moving to the right. Okay, so if I have like some surface here, the wave, this point is going to be the first point that hits that surface, and then it'll continue going into that surface, whatever that is. Okay, so some terminology here. You know about wavelength now. So the wave is, or the wavelength is basically the length of one wave, one complete wave. Now, one thing about that second video, you talked about nodes in here and said the distance from one node to the next. I didn't really like that because the wavelength, if you, and I don't even like calling this a node right now, but if you call that a node, then the wavelength would be to this point. Okay, it would be the second node, as he called it in that video. Don't worry about that word node right now. We are going to use that, but in a different context later. Okay, so this then is the wavelength, okay? And that can be, from any point on the wave to the next point. And he talked about it could be from crest to crest. It could be from a trough to a trough. It could be from this point to this point. One complete wave is the wavelength. Now, the symbol we use for wavelength is the Greek letter lambda. Okay, so it's that symbol. Many of you have probably seen that in math class, but that's what we use for the wavelength. Okay, now a couple other things, a couple other terms we talked about in uniform circular motion. They come up here again, so I'm going to go over them real quickly. So a capital T is period. Okay, so the period is going to be time I'm still not good at drawing or writing on this. Time for one complete cycle. And that'll be in seconds. Seconds. Okay. So in this case, it'd be one complete wave. So again, if we have a stationary surface here and the wave is moving to the right, it's by the time this point in the wave gets to that surface, that would be a period. Okay. So similar to period, we have frequency. Okay, and frequency refers to the number of cycles per second. Okay, so the units for frequency, we could say cycles per second, or commonly we have hertz. Hopefully you remember that from circular motion first semester. Okay? Okay, so period is seconds per cycle. Frequency is cycles per second. So you can probably see that they're inverses of each other. Okay? So the frequency is just 1 over period. All right? So if you know one of them, you know the other. Pretty straightforward there. Okay? So now let's look at the speed of the wave. So the speed of the wave, there's a very, we had net force equals mass times acceleration, we had V equals IR. Well, next we're going to look at the big equation for this unit, which is actually a very little equation, just like those others. Okay, so again, if we have a wave moving to the right, we want to calculate its speed. So speed, we know, is distance over time. Okay, so distance we have defined here for a wave would be wavelength. Okay, that's a defined distance that the wave would travel. So we can say speed, the distance we can say is wavelength. Now for the time, we need a corresponding time with that wavelength. We can't just pick any time. It has to correspond with that wavelength. So now we have that defined as period. Period is the time for one complete wave. So that would be one complete wavelength. So we could write an equation like this. So we could rewrite that as speed equals wavelength divided by period. Okay. Wavelength, of course, we want that in meters. Period is in seconds, so our units here would be meters per second. All right. Now I want you guys to come up with another equation for wave speed, but in terms of frequency instead of period. So pause right now, figure that out, and then hit play once you have it. Okay, so you all got it, right? Well, remember, frequency is 1 over period. We could rewrite this equation, V equals wavelength times 1 over period. Well, 1 over period is frequency. So then that gives us V equals frequency times wavelength. Okay, this is the most common form of the wave equation you're going to see. This one makes a lot of conceptual sense, to me at least, but this is the most common form you're going to see. And again, we're working in meters and seconds there. Make sure you watch your units. I'm still seeing that mistake a lot. Make sure you're watching your units. Meters, seconds should be your units for these, always. Okay? All right, that's it. There's going to be an assignment for you to do on a FET simulation. I think we've done 1 or 2 of those in the past, but that should be a good one. That will lead into tomorrow's lesson. So please do a good job with that, and then you'll be ready to go tomorrow. All right, see you later.